Hello everyone, I Nikhil welcome you to Vigyan Bharat. Today we're going to continue the second part of our title Direct Sum. Last time we have already covered the part 1 in the previous video. So first let's discuss the outline of today's lecture. We're going to cover two important topics today. First, the condition for checking whether a given sum of subspaces form the direct sum or not. And second, when we are given two subspaces, then what will be a testing condition for through this condition we'll be able to check whether the given two subspaces form a direct sum or not. And there is some useful information here that you should watch the previous video part 1 of the direct sum in case you are watching this directly. And second, in the lecture I might go slow sometimes because everyone should understand, so you can watch it at 1.25 or 1.5 depending on what suits you. So, and finally, this one is very important because I get some messages from some students that they find it difficult to understand the English. So what I have found a good idea is that at the end of the video, I'm going to summarize everything in Hindi if in case they have any doubts anywhere when I explain the lecture. So without any delay, let's get started. So let's first start with the first result, that is condition for a direct sum. So let's first try to understand the statement. What is the statement? Suppose we are given m subspaces of a given vector space V. V is some vector space and we have m subspaces which I have denoted here by capital U1, U2 till Um. Here, these are my m subspaces of this given vector space. Then what the result is, then this sum, this sum will going to form a direct sum if and only if, this is for if and only if, the only way to write the zero vector as a sum of the elements u1 plus u2 plus u till um, that is basically an element of this set here, only by taking the choices for these ui equals to 0. That is, I can express my zero vector, if I can express my zero vector only as a trivial linear combination of vectors coming from these subspaces, then this given sum, this sum of subspaces form the direct sum. That is here. This is my zero vector of the vector space V, and if I want, if I can express this in this form, that is only uniquely if I can express this only in the trivial linear combination of these vectors. Here, this u is coming from this capital U1. This is not u, this is 0. This zero vector is coming from the subspace capital U1, of course, because it's a subspace, so by definition it should have zero vector. And similarly, this is coming from U2, and finally this is coming from Um. If we'll be able to show that the only way to express this is in the trivial combination, then the given sum forms subspace. So this is our first result. And the second is a very important testing condition. If I am given two subspaces, and I have to check whether those two subspaces, the sum of those two subspaces form a direct sum or not, only I have to check this condition, testing condition, that is their intersection should equal to only the zero vector. So let's first prove let's prove this condition for a direct sum. So what we can do, let's create some space over here. Let me drag this down, some space. Okay, this has remained here, no problem, no issues. And you also come down. Just a second. Perfect. So let's go back. First, we have to try to prove this one. Because the statement is if and only if, so whenever we have an if and only if condition, so we have to prove two ways. First, the forward way, which we also call as necessary condition. necessary condition, and the backward way, that is sufficient condition. Sufficient condition, that is, you can understand it like this also. Suppose in general I am saying now, if there is some condition P and which holds the phenol leaf with Q, if you want to prove this one, and if you prove that P implies Q and Q implies P, then this is same as saying this, that P is phenol leaf Q. Okay, so now my P here in my case is that I'm given this sum is a direct sum. This is given to me. So let me assume that, just a second, let me, yeah. So what I am assuming, I am first proving my necessary condition, the forward part. That is, I'm given that this sum is a direct sum. Basically, I'm given this. This is given to me. Then by definition, which we have already studied in the previous lecture also, by definition of direct sum, this implies that the only way to write zero vector is in the trivial way, 0 plus 0 plus 0, where this 0, this guy, this 0 is coming from this subspace, this 0 is coming from here, likewise this 0 is coming from here. So this forward condition is straightforward. Using this, we have proved that the only way to express 0 is only the trivial way. Now let's try to prove the other way around. That is, now I assume, just a second, the sufficient condition, that now I'm assuming that the only way, what I'm given, the only way to write my zero vector is only the trivial way. Here, of course, again, these zeros are coming from u1, u2 till um respectively. Now, what I want to prove, that given the subspaces u1, u2, u1, u2 till um, so I was saying that we are given m subspaces u1, u2 till um. Now, with the given information, our aim is to prove that their sum forms a direct sum. That is this. This will be our aim to prove. If we are given that the only way to express the zero vector as a sum of elements of the subspaces is only the trivial way. So that we're going to prove. So what I'm going to do, let I assume, suppose let there exists an element x which belongs to this sum. Then if it belongs, then by definition of sum of subspaces, there exists some u1, u2 till u1, u2 and so on till um, such that this ui belongs to capital UI for I running from 1 to till m. That is, every ui is a element of the subspace capital UI. Then if it belongs to this sum, I have the representation of x as u1 plus u2 and so on um. I can express my x as a sum of these m vectors coming from those subspaces. Let me note it by 1, because now I'm interested to prove that this x, if this x have only this representation as a unique representation in terms of the corresponding vectors coming from those subspaces capital UIs, then I'm done. Then there's some form of direct sum, but that we have to prove. So what I assume, that in opposite I assume something, that this x has another representation. This x has another representation in terms of as a sum of the elements of those subspaces. Representation. So if it has a representation, then again there exists some, suppose, vectors, and this time I call them v1, v2 till vm. Again these vj's are coming from those same subspaces, capital Uj. Now my j is again running from 1 till m, 1, 2 till m. So now I can express again my x as sum of these m vectors. Let me call it 2. Now I have two representations for my element coming from this sum. Now if I subtract my 2 from 1, subtract equation 2 from equation 1, what I found on the left hand side, this x will cancel itself. So on the left I have the 0. Observe the 0 is a vector here because I'm taking the difference of a vector. So the answer is in the same space. 0 equals u1 plus u2 and so on plus um minus v1 plus v2 plus vm. If now I rewrite this expression as u1 minus v1 plus u2 minus v2, basically what I'm doing, I'm taking the difference of the vectors I'm rewriting as the difference of the vectors whose index is same, um minus vm. Now try to observe here something there's an easy observation. Now what is the observation here? Since we know that u1 is already an element of capital U1, v1 is also an element of capital U1. Since u1 is a subspace, this implies that minus v1, if you multiply by scalar minus 1 to v1, then it again belongs to capital U1 because U1 preserves scalar multiplication. Then their sum, if I add these two, then again this element, this one, belongs to capital U1 because U1 is subspace, so it preserves addition of two vectors in it. Likewise, this here, this belongs to u2 and this belongs to um. The 0 vector is now we are able to write the 0 vector as a sum of elements from these subspaces. But because in the starting what we are given, that the only way to write the 0 vector is the trivial way, this we are given. So if now I use this one in this equation here, what I get, that each of these factors has to be 0 in order to satisfy this condition. So u1 minus v1 should be equal to 0, u2 minus v2 should be 0, and so on. um minus vm should be equal to 0. So this implies u1 is same as v1, u2 is same as v2, and so on. um is same as vm. So what we have shown actually, that in starting I assume that there are two representations for my given x if it is an element of a sum of these subspaces, but what I concluded that these are same, basically these are same, so there is only a unique representation which I have proved here. So I'm done here. Then therefore that sum forms a direct sum. This completes the proof of the other way. So this completes the proof of this result. The proof of this I will going to do in a separate video, adding some examples to both these results I will do in the next video. So what now at the end before concluding, what I'm going to do, just a recap of what we have done today in Hindi. So जो हमारा पहला कंडीशन था उसमें हमें क्या गिवन था कि अगर हमारे पास कोई एम सबस्पेसेस हैं तो उनका जो सम होगा वो डायरेक्ट सम कब बनाएगा, जब जब हम जो जीरो वेक्टर है हमारा उसको हम एक ही तरीके से लिख पाए. दैट इज ओनली द ट्रिवियल वे. अगर उसको हम उस तरीके से लिख पाए अपने जीरो वेक्टर को, तो जो हमारा सम था सबस्पेसेस का ये, तो वो एक डायरेक्ट सम बनाएगा. तो इसको हमने प्रूव करने के लिए अगेन नेसेसरी कंडीशन एंड सफिशिएंट कंडीशन दोनों को प्रूव किया. सबसे पहले हमने जब नेसेसरी कंडीशन को लेके चले थे तो उसमें हमें क्या गिवन था कि हमारे पास एक डायरेक्ट सम गिवन है. तो जो हमने प्रीवियस वीडियो पढ़ी है उसके हिसाब से बाय डेफिनेशन वी नो अगर कोई सबस्पेसेस का सम डायरेक्ट सम फॉर्म कर रहा है तो जो वहाँ पे जीरो वेक्टर है उसकी खाली एक ही रिप्रेजेंटेशन है. और वो रिप्रेजेंटेशन कौन सी है, जब आप उसको एक्सप्रेस कर सकते हो खाली एक यूनिक जीरो वेक्टर्स के कॉम्बिनेशन के फॉर्म में, जीरो वेक्टर्स के सम के फॉर्म में. तो यहाँ पे जो हर एक वेक्टर आ रहा था कैपिटल यू आई से फॉर u1 i रनिंग फ्रॉम u1 टू टिल m, हर एक से वो कौन सा वेक्टर हमें मिल रहा था, जीरो वेक्टर. तो मैं अपने जो ओरिजिनल वेक्टर जीरो को खाली इसी तरीके से एक्सप्रेस कर पा रहा था. तो ये तो हमने नेसेसरी कंडीशन को स्ट्रेट फॉरवर्ड प्रूव कर दिया, ये तो बाय डेफिनेशन हो गया. अब जो हमें सफिशिएंट कंडीशन प्रूव करनी थी उसके लिए हमें गिवन है कि जो हमारा जीरो वेक्टर है उससे खाली यही रिप्रेजेंटेशन है और उसको हमें शो करना है कि जो हमारे एम सबस्पेसेस हैं जो अगर इनका सम होगा विद दिस कंडीशन तो वो क्या बनाएंगे, डायरेक्ट सम बनाएंगे. तो उसके लिए हमने क्या किया, सबसे पहले एक एलिमेंट ले लिया जो कि उस डायरेक्ट सम से हमने एक एलिमेंट ले लिया उस सम से. तो हमने देखा कि उसकी रिप्रेजेंटेशन अगर उस सम में आ रहा है तो ये वाले वेक्टर्स आएंगे उन सबस्पेसेस से जो कि हम अपने एक्स को ऐसे एक्सप्रेस कर सकते हैं. लेकिन क्योंकि हमें प्रूव करना है कि एक्स की एक यूनिक रिप्रेजेंटेशन है तो मैंने सपोज ऑन द अपोजिट आई एम प्रूविंग इट बाय कॉन्ट्रडिक्शन. मैंने मान लिया कि सपोज एक्स की एक और रिप्रेजेंटेशन है तो मेरे एक और ये वाले वेक्टर्स आएंगे उन सबस्पेसेस से सच दैट मैं एक्स को इनके सम में एक्सप्रेस कर सकता हूँ. अब यहाँ से जब मैं इन दोनों का डिफरेंस लिया हमने फर्स्ट और सेकंड इक्वेशन का, तो हमें वो किसके बराबर मिला, जीरो वेक्टर के. जब हम लेके चले थे इसका प्रूफ करने के लिए सफिशिएंट कंडीशन को, तो हमें पता था कि जीरो वेक्टर का खाली एक ही वे है लिखने का, ट्रिवियल वे. तो यहाँ से जो ये वेक्टर्स हैं सारे, इनको उस कंडीशन को सेटिस्फाई करने के लिए यहाँ पे क्या होना पड़ेगा, सबको जीरो होना पड़ेगा. तो उसके वजह से हमने ये सारे फैक्टर्स को लास्ट में जीरो इक्वल इक्वेट किया और वहां से हमें मिला कि जो हमने दो डिफरेंट रिप्रेजेंटेशंस ली थी वो एक ही रिप्रेजेंटेशन है. लास्ट में हमें कंक्लूड कर दिया. तो वो कंक्लूजन कैसे है, क्योंकि जो हमने माना था कि दो रिप्रेजेंटेशन हैं वो गलत है. तो इसलिए यहाँ पे बेसिकली हमने कॉन्ट्रडिक्शन लेके आए हैं इस स्टेप के अंदर. यहाँ पे कि हमने माना था कि दो रिप्रेजेंटेशन है लेकिन हमने लास्ट में कंक्लूड किया खाली एक यूनिक रिप्रेजेंटेशन. तो यहाँ से हमने दिस वी प्रूव्ड दैट देयर सम फॉर्म्स अ डायरेक्ट सम. सो आई होप कि आपको आज का वीडियो समझ में आया होगा. अगर आपका अभी भी इसमें कोई भी अगर डाउट्स एनीवेयर देन यू कैन ड्रॉप इन द कमेंट सेक्शन. And before concluding the video, there is an important information to all of you that find some relevant links in the description of video. Like you should join our Telegram group. There we are every day we are like updating some good problems and the students are interacting. So there's a good discussion going on. So you should also be a part of our community there. And finally, if you're new to our channel, then please do subscribe it. And if you find the video to be useful and interesting, then do give it a like and do share it about our initiative among your friends if they are preparing either for IIT JAM Mathematics or IIT JAM Statistics, or if they are interested in learning some good subjects of mathematics like what we are doing right now, linear algebra and some more subjects, real analysis, calculus, and so they should be part of our community. Definitely our content will going to help them. So I'm going to conclude this with this today video. So thank you so much for watching and we'll meet again in another video. Thank you so much.